Hello, guys. I'm going to talk about an interesting topic today, and this is probably one of the most common fundamental topic in physics, which is Newton's laws of motions. And what the change I've done right now, I'm going to start using some notes. And these are the notes that I've created, so it's nothing crazy. But the only reason I'm going to use this is just to keep on track and try to stay focused on how we progress or on how I explain things. And I'm going to try to keep it super basic and super fundamental. That way, first is to make it fun and easy to understand. And second is to leave all the math and equations and everything crazy out of it. So, my first thing, right? Like, why do laws of motion matter, or why do we even need to understand them or learn about them? So, basically, the laws of motion are fundamental and they provide a basis for a classic mechanics. Now, what is a classic mechanics? You must be standing on you must be standing on ground, you are sitting in a chair, or you are moving in a car. All these things, for it to happen in that specific order, for you to perform those actions and those motions, you have to follow the classic mechanics, or the fundamental laws of motion. And hence, there's a reason why we need to know about them, or why we need to learn them. Like, how do you get water at home? Why does the water flow? Or why does the ball fall down when you throw up in the air? Or why does the ball bounce when you hit it on the floor? So these basic questions are answered understanding Newton's laws of motion. So there are three laws of motions, obviously, and now you could break them down or go even further in and explain how these laws of motion extend to multiple different like sub laws, or whatever you want to call. And if you read a little bit more physics 101, you'll kind of understand what I'm talking about, how the whole kinematics and kinematics equations are developed. So the first law of motion is essentially something that you kind of do every time and something that you kind of see every time. However, you just haven't defined it yet. That is the first law of motion. And the law states as the body, I'm going to try to explain it a little pictorial. A body tends to be in a state of rest or in a uniform motion. A body tends to be in a state of rest or in a uniform motion in a straight line. Until and unless influenced by an external force. What that means is, if I am standing, I'm going to be standing straight. If I'm moving, I'm going to be moving straight. If I take a ball, or let's take this pen, it's sitting there. Or let's take this pen, it's rolling down. So a body tends to be in the state of rest or of uniform motion in a straight line until and unless acted upon by an external force. So this is at rest. External force, my hand. I push it, it moves. The body is in a uniform rolling motion. I stop it. External force, I stopped it. It stopped moving, or it stopped accelerating. So that essentially is the first law of motion. The second law of motion, and this is kind of interesting. This is where it gets a little bit more mathematical, although not super complicated. So basically what the second law states that, so force equals mass times acceleration. Now, we could go a little further. The mass of the body is what the mass of the body is. what is acceleration? Now you hear this, you're in a car and you are driving and you want to pass someone, and the basic instinct is hit the foot on the pedal, accelerate, right? What does acceleration means? It's change in time, or change in velocity. That's delta V, change in velocity with the change in time. I'm not try to keep it simple and not go too crazy on the mathematics as I explained, or any equations. So mass equals change in velocity. I'm moving at a constant speed, right? Or constant velocity. So V1 minus V2, change in the time, T1 minus T2. So essentially what that means is higher the mass, higher the force, higher the acceleration, higher the force. So if you are basically, if you take a ball, a tiny little baseball ball, and you throw, let's say the acceleration is constant. So the change in the velocity of the ball is constant with change in respect to the time. So let's say you take a little baseball ball and throw it, versus you take a big watermelon and throw it at the same velocity. The force asserted by the watermelon is going to be more, just purely based on the mass. Or let's do it the other way. You take a baseball and you take a watermelon and you throw both of them. And if you want both of them to exert the same amount of force, the only thing you have to do is adjust your acceleration. So if a baseball dropped on a wooden plank, breaks the wooden plank, and a watermelon dropped on the wooden plank, breaks the wooden plank, watermelon is falling at a slower acceleration. Hence, they both are exerting the same amount of force. The third law of motion is pretty common and the most widely heard law that you probably would have heard everywhere, everyone saying it, more in terms of psychologically, but what it means is, or what it says is, every action has an equal and opposite reaction. Now, again, as I mentioned in like one of my first statements, right? You take a ball, you throw it down, it hits the ground. So it comes down, it hits the ground. Now, when the action of throwing, going back to this second law, force times acceleration, when the ball hits the equal amount of normal force, meaning the force exactly in the opposite direction in which it hits, following the first law, in a straight line, is going to be exerted on the ball, and the ball is going to kind of go back up. Now, you could do this with anything. You could use like one of the best examples of like a rocket ship. You have the rocket, the rocket ignites. Let's use orange. The rocket ignites. What it's doing is right now it's exerting heavy amount of force, and that heavy amount of force is pushing it back up straight in the sky, in the air, in the space. So the third law of motion is pretty simple. It's every action has an equal and opposite reaction, and you can kind of tie it back to the second law on how your acceleration and mass is gonna downwards equals the acceleration and mass upwards. And you can also tie it down to the first law on how every action has an equal and opposite reaction. So the reaction is always going to be normal. The word normal is really important, and it's in a scientific or in a physics perspective, what the word normal means is back in the straight line, or back perpendicular to which the force was exerted. So that's essentially, these are the three laws of motions. And if you understand these, if you kind of understand these completely and know what these laws stand for or how they work, you can keep expanding this into different kinematics equation, understanding what a momentum is, understanding what impulse is. And Hence, the Newton laws of motions are really fundamental and important. I hope you enjoyed this. Thank you.